All right, we're into lesson 2, student-driven pacing. For me, out of all of the lessons in this entire mini course, this is the one that's most important to me. If you can understand student-driven pacing, if you can understand what I'm trying to convey here, it ripples out into everything else. I really see this as the foundational lesson, and it is the most important thing in it to me. So to kind of give you an idea of what I'm talking about, let's look at what are some possible issues. So you have what I call the double bell curve, where you got your best and your brightest are getting it, and then there's this gap, and then kind of there's everybody else. And a lot of your students are kind of in this low B, upper C range, or even in mid B range, be shifted a little bit. But there's this gap here that your best and brightest are up here, and then there's kind of everybody else, but there's this gap. And to be honest with you, I don't think that gap has to be there. I think we can close that gap. Or are you having to reteach a lot? Like you explain something, you give a kid a quiz or a test, and they bomb the stew out of it. And you're like, oh my gosh, what's going on? I got to reteach this. And then you take the time to reteach it. Or your kids are just not prepared for any test that you give them. You can tell they're not prepared. So those are the issues that, to me, speak of some issue with pacing. And when we looked at the two of the enemies in the first lesson, to me, confusion and boredom are also issues with pacing. Now, if you're going too fast, kids are going to be confused. If you're going too slow, they're going to be bored. And so we need to use those as kind of, when we see them, we're like, oh, wait a second, those are kind of like red flags. Those are things that I need to be aware of and be paying attention to. And so let's look at student-driven pacing and what I mean by that. What I mean is this. So think of a unit as a building or a house. And that when you start building things, so let's take nomenclature, for example. Naming chemical chemical compounds and writing their formulas. So, to me, I start with covalent, so that's down here. So I lay my foundation with, hey, you got to know your elements and their symbols and their names, and here's how it works. You got these elements of, non-metal with a non-metal. That's all covalent. And then I add ionic, and then we put it all together. And I look at them that way in terms of pieces. So I break everything into pieces, but then I don't move on until I'm done. Could you imagine trying to paint this door or put in these windows if you haven't finished building the wall? Could you imagine trying to put on a second floor wall if you haven't finished building the first floor walls? It doesn't work well. Like I get teachers who get talked to that are frustrated that their kids can't do mole conversions. And I'm like, can they do regular conversions? They're like, well, they struggled with it. I'm like, then go back and do those. Because if kids can't do regular conversions in their sleep, then they're going to have a hard time doing mole conversions. If they can't do mole conversions, then they're not going to be able to do stoichiometry. And if they can't do basic stoichiometry, they're sure as heck not going to be able to do limiting reactants and percent yields. Everything builds. And so you've got to be aware of what's going on. That every unit builds on the previous one a lot in chemistry. And there's a lot of overlap in skills. And so we as teachers have to be aware of that, of how to break up a unit and assess as we go along. To me, the key to this is assessing as you go along. You have to assess. You have to know, all right, do my kids get this first piece before you move on to adding the next piece? So going back to nomenclature. When I'm teaching ionic nomenclature, I make sure my kids understand binary first, a metal plus a non-metal. That's the first thing I cover. Do my kids understand, that you got to use, ion, you got to get the charges to cancel out. You put ID on the end. Do they get that? And once I'm comfortable that they know how to do that, then I transition and I add polyatomics. Then I want to make sure they understand polyatomics. And we're going to make sure they understand ates and ites and perates and hypoites and hydrogen carbonate and all the different variations on polyatomic ions. And then I'm assessing as I go along. And we'll look at the different assessment ideas here in a minute. But I'm assessing as I go along. And so when I'm comfortable that they have a good grasp, and once again, I'm not when I say a good grasp, I don't mean like complete perfect mastery, but I mean the majority of the class gets it. And once again, I can't do everybody in class. There are some kids who are going to have to come in for extra help. That's just the nature of the beast. And you're going to have some kids who just aren't willing. And if they're not willing, there's not much I can do about it. Once again, that's where it's important what we talked about in lesson 1 of like, what's my responsibility? My responsibility is to help every willing student learn and to assess them and kind of pace based on where they're at. But if a kid's not willing, then that's their choice and not my responsibility. I need to communicate that to them. I need to communicate that with their parents and with administrators. But I'm not going to take that on me. Every kid I've ever had fail my class, which have only been a few, thankfully, but every kid I've ever had to fail my class, I know they failed because they chose to. They chose to not do what they needed to do. But I'm always assessing along the way. I'm assessing what's going on. I'm checking in with my kids. If I've got a kid who's just slowing down and not catching up, I need to communicate with them. Hey, you need to come in before school. You need to come in after school. Hey, check in with me during your study hall. Those kind of things. I need to take steps along the way to make sure my kids are ready to move on when we need to move on. Right? So that's a big piece of it all. And then at the end, because I've broken it into pieces, it's important for me to bring it back together. Otherwise, my kids can be like, oh, these are polyatomic ions over here. This is covalent over here. This is transition metals here. And to them, it's different pieces. It's a random window, a random door, a random balcony, whatever. But I'm like, no. These pieces go together. They make a picture. Or these parts go together and they make a house. So I need to show them, hey, here's how we do ionics and covalence together. And here's how you do polyatomics. Some of your questions are polyatomics. Some of them are nonmetals. Some of these have regular metals, representative metals. Some of these have transition metals. Mixing it all together, bringing it all together, and showing them how everything fits together. That's also kind of a critical piece that I think sometimes gets lost when people break things into pieces. And so that's critical that we do that here. So why should you do this? All right. I'm a firm believer that if you take an extra few days early on to assess where they're at, take the time to assess where they are, and slow down, go over it again. If the kids need an extra day to understand binary ionics, like I think binary ionics should take usually about a period and a half, maybe 2. If for some reason I'm having a group that's struggling with it, and it's going to take 3 days for them to get it, I'm going to pay that price every time. Because if I don't take the time, I'm going to lose that time later, if not more. And so it's critically important that I'm willing to pay the price to lay a firm foundation in order to save me headaches later. For example, when I'm doing conversions, if I teach conversions really, really well, and this is one of the places where I do things differently than most people. I don't teach conversions at the beginning of the year, where most chemistry books have it, because I teach it and then I don't use it until I get the moles much later, and kids forget it, and I have to reteach it anyway. So I just shift it to right before moles, and I teach it for the first time right then. And so I teach conversions right then, and I make sure they get conversions, and we do lots and lots of conversions. I want them to be able to convert. If I want them to convert whatchamacallits to doohickeys to sprockets, they can do it. That's what I'm looking for. I want them to be able to do conversions in their sleep. So that when we get to moles, all I'm doing is adding a couple new conversion factors. And they get it. And it's quick. And it's easy. And then I make sure they understand mole conversions. And they can do mole conversions in their sleep. When we get to stoichiometry, all I'm doing is adding an extra step. That mole to mole step using a balanced reaction. And it's easy peasy. Kids blow right through it. Because I've laid this amazing foundation, and I'm like, hey, let's add this new piece. Oh, okay. And they add it. And then, hey, let's add this new piece. Versus the other way around. If I blow through conversions, or I teach it at the beginning and I just blow through reteaching it, and my kids are a little wishy-washy on conversion. They're like, a third of the time they're flipping things and getting things in the wrong place. with simple things like feet and inches, they're going to do it even more when they get into moles and grams. That's abstract. They don't get that. At least feet and inches they get. They understand what a foot is and they understand what an inch is. But if I don't lay that foundation, then they're confused. And if I just keep pushing on because I have some schedule that I have to keep and I can't give up a day, I'm going to lose my time or I'm going to lose my kids. Once they start bombing tests, they just give up. Once they get confused, they give up. I've lost them. And sometimes you lose them for the rest of the year. Sometimes you lose them for the rest of the unit. And I'm not willing to lose them. And that's why I do this. So, which then begs the question of, all right, if you're slowing down to make sure the kids get it, what do you do if you don't have time to cover everything? I've got an administrator who says, I have to cover everything in the next gen science standards, or I got to cover everything that the state of Texas says I have to cover. Well, then you got to prioritize. And you go onto my Facebook page, sometime last spring, I did a live on this very topic of how to prioritize what units are most important. For me, it's nomenclature, reactions, moles, stoichiometry, all of that. That's to me the most important. And then even when I get in the second semester, I have to kind of know equilibrium and solutions and phase changes and heats and reaction, all those things. I have to decide what's most important. And then I have to decide which ones do I want them to have mastery in, and then which ones do I just want them to have some exposure to. Because it doesn't say that, the standards generally don't say they must know it to this level. The standards just say you have to teach it. And so sometimes this exposure works. For example, for me, nuclear chemistry. I find it drives me nuts that it's even in most science standards, because the only time I've ever seen nuclear chemistry, and I have a chemical engineering degree and a degree in chemistry education, the only time I've ever seen nuclear chemistry is in a high school chemistry class. I never saw it in college in chemical engineering. I never saw it in college when I was working my education degree in chemistry. I didn't deal with it. It's not something that we interact with. And so for me, that's an exposure topic, and I cover it very, very quickly. I tack it on to the end of my atomic theory unit, and I may spend a day and a half total, and I may have a few questions on the test. It's not important to me. It's not going to get its own quiz. It's not going to get its own lab. It doesn't need it. I'm just going to cover it, give it to my kids, and move on. Because I have other areas that I think are more important, that I think are more, that I've made a priority, that I'm going to put my time into and make sure my kids get that. That's how I make up my time to be able to do this. But really, I believe at the end of the day, if you do student-driven pacing, you'll make up your time on the back end. That I make up any time I lose here on conversions and making sure kids get that, I make up here and here. I really do think it just saves me time as I go along. All right, so that's lesson 2. So let's look at action steps. Identify the key content areas for your current unit, or even think about it in terms of a year. If you're early on in the school year, think about where you are for the year. Think about what's most important and where you want to put most of your time. And be willing to, shorten other areas to compensate. Or if you're in the middle of the year, think about the unit you're working on right now. What's the key content? And then determine how you're going to assess the students along the way. Because even within a unit, you need to break it up and prioritize. But then you got to assess along the way. And there are multiple ways to do the assessing along the way. You can do homework. You can grade, collect, and check homework. You can do quizzes. You can do labs. You can do alternative assessments. I wouldn't wait for the test. I think that's too late to be doing that. But homework, quizzes, just how you interact with them in class, how you ask questions in class. We'll get to a lesson on that. I think is a really great way to assess where they're at. And so there are different ways to do that. So start thinking about that. But really, lesson 3 is going to be my favorite way to assess where they're at. And that's on how I use class time to maximize instructional value. And so I look forward to seeing you in lesson 3.